In this video, we'll be going over 5 challenging derivative questions. So here is the first problem. It states that y is equal to ln of x squared plus 1 all over square root of x. Pause the video and try this for yourself first. Now if you've done that, let's try to go over it together. So we're essentially just trying to find dy dx. We can do that by applying the derivative operator d dx to both sides. So we get that dy dx is equal to the derivative of ln of x squared plus 1 all over root x. This is where the derivative formula, derivative of ln of some function u comes in. And that is just equal to 1 over u times du dx. And in this case, our u is just whatever's inside the ln. Right there here. That is what our u is. So what do we want? 1 over u, which is the reciprocal of u. So we just flip whatever's in there, which is going to be square root of x over x squared plus 1. And it's going to be that multiplied by the derivative of the whole input. Alright, so computing the derivative, you notice that it is a quotient of 2 different functions, and that's why I have the quotient rule already written down here. We can apply that right here. Now this time it's the same as if this top part is u and this bottom part is not u, I meant v. So just applying the quotient rule, we get that it is root x multiplied by the derivative of the whole thing x squared plus 1 minus the whole thing x squared plus 1 multiplied by the derivative of square root of x. And it's going to be all of that over the square root of x squared. And so I'm just going to keep this left part the same here. Write that better. And it is going to be x squared times the derivative of x squared plus 1. Well, the derivative of 1 is just 0 and x squared is 2x. So you get that it is 2x minus it is going to be x squared plus 1. That stays times the derivative of square root of x, which is just 1 over 2 times root x. And it's getting all that over x because the square root and the square cancels. And now we're right here. Let me just rewrite this as an actual quotient. So it's going to be x squared plus 1 all over 2 root x. Alright. I'll also distribute the minus. And so at this point we can just multiply the 2 fractions. So you notice that we have we're just going to distribute, of course. And so these two, the roots will just cancel out, and this square root will also cancel with this square root of x. So we are gonna get, let me just write the big fraction here, and we'll get x times 2x minus x squared minus 1 all over 2. And here I'll just leave it as x times x squared plus 1. And I can also rewrite this as 2x squared. And for this part right here, I'm just going to rewrite this as a denominator of 2. So we can just do that by multiplying the numerator and the denominator by 2. That gives us 4x squared. It's going to be over 2 minus x squared minus 1, 2 all over the same denominator, like so. And then, of course, we can just simplify this part right here. We get 3x squared minus 1. And since it's this over this over this is the same thing as writing, it's the same thing as ignoring this and just doing division by our denominator. And so what does that mean? That means our final denominator can be written as this, because our 2 just goes there. And that will be your final answer. So now here is the second problem stating that y is equal to x squared times sine of x times e to the x. Pause the video and try this for yourself first. Now once you've done that, let's go over it now. So what you notice here is actually it is a product of three different functions. In this case, x squared, sine x, and e to the x. And we can actually just apply the product rule here. The only difference is that this time there are three different functions. So now you can actually just generalize this. I just basically, I've never seen this before, but anyone can probably derive this if you already know the product rule. So this is basically how I would go on about this. So I just use the product rule, but as if there are three functions. So now we have like the derivative of three functions being multiplied by together. It's, well, that's quite long, but it is whatever this is. And we can actually simply just apply that here. So applying the derivative operator to both sides, we get that dy dx is going to be equal to the first two functions, x squared sine of x, times the derivative of our last one. It's going to be this plus our last two functions. Doesn't really matter in what order you do it, but it's going to be sine x e to the x times the derivative of our first one plus, finally, it's going to be the first and the last function, which is x squared times e to the x, and it's going to be that multiplied by the derivative of our middle one. The derivative of sine x is getting a little squished here. And so now we can just compute the derivatives. You get that x squared sine of x, the derivative of e to the x is just e to the x, plus sine x e to the x, the derivative of x squared is 2x, plus x squared e to the x, and the derivative of sine x is just cosine x. At this point, we can just factor out whatever common factor we have, which in this case is just e to the x. And we get, not e to, you get x squared sine x plus 2x sine x plus x squared cosine x. And that will be your final solution. So here is our third problem. It states that y is equal to e to the x minus e to the negative x. Go ahead, try this one for yourself first, and we'll go over it. So once you've tried it, let's see. So like always, we just apply the derivative operator to both sides. So we get the dy dx is equal to the derivative of e to the x minus e to the negative x. Now, here, I'll just write that here. What you notice is that this is the same thing as e to the x to the power of negative 1 by the exponent rule. And so we can just compute the derivative of our first one here, which is just e to the x. And it's going to be minus the derivative of e to the x to the power of negative 1. We can just use the power rule here. We get that it is negative 1 times e to the power of x to the power of negative 2 by the power rule. And we get that we get e to the x minus, or actually we can just make this a plus here, and it's gonna be, oh, and I forgot here. It's gonna be that, and it's gonna be the derivative of e to the x. So this might be a little confusing, but that is because we are just using the chain rule here. So we use the power rule for this, so that's why it became negative 2 here. And then since we still have the inner function, we can just get the derivative of this right here. So it's just another application of the chain rule, and we get 1 over e to the x squared, right? Because that is simply just this. And then we have to compute the derivative of e to the x, which is again just e to the x. And then this is the same thing as e to the x to the power of 1. And so we can just use exponent laws to cancel that out. And we get e to the x plus 1 over e to the x. That is also the same thing as e to the x plus e to the negative x. And that would be our final solution. So here is the fourth problem. It states that f of x is equal to 2x plus 1 cubed times sine of x. And what you notice here is that it is a product of two different functions. In this case, 2x plus 1 cubed times the second function sine of x. So we can just apply the product rule. And so it's just going to be the first function times the derivative of the second plus our second function. Our second function times the derivative of the first, which is 2x plus 1 all cubed. Okay. And so let's just compute the derivatives. It's going to be 2x plus 1 cubed times the derivative of sine of x, well, that is just cosine x, plus sine of x. And the derivative of 2x plus 1 cubed is just, we apply the, the power rule, but we have to be careful here. Yes, the 3 will just go in front. It's going to be 2x plus 1 squared, but you notice that in this case we actually have an inner function, so we're going to apply the chain rule. And then we're going to get it's going to be that times the derivative of whatever is inside, 2x plus 1 in this case. And so what is that? That is just going to be 2, because the derivative of 2x is 2 plus the derivative of 1 is just 0. And rewriting that, we get 2x plus 1 cubed times cosine x plus sine x. And it's going to be this times 6, because that is just 3 times 2 times 2x plus 1 all squared. And that right there will be your final solution. So here is the final problem. I'll tell you right now, this is probably gonna take quite a while. But anyways, it states that y is equal to sine of 3x plus ln of x plus 2 all to the power of tangent of x. So immediately, the challenging part is that it's not an exponential function quite. It's not also quite a power function, as in like it is not a constant to the power of some function, but it's also not some function times to the power of a constant. Rather, it is a function to the power of the function of a function. So the first step here, pretty interesting, is actually to take the ln of both sides. So we get ln y is equal to tangent x times ln sine 3x plus ln x plus 2. Now this makes things a bit easier, because now it's not a function to the power of another function, but now it's just a product of two functions. Except that our y is not fully isolated. So at this point, if we take the derivative of both sides, we're actually gonna need to implicitly differentiate for y. So we get the derivative of ln y is equal to the derivative of this whole thing here. And here we can just apply the product rule. It's gonna be tangent x times that whole thing here. So it's gonna be tangent x times the derivative. I'll just write it as derivative of ln of sine 3x plus ln x plus 2. And it's going to be that plus this whole ln stuff times the derivative of tangent x, which is, I'll just write that here, which is just secant squared x. Secant squared x. Alright, so now we're here, let's try to differentiate the left side here. The derivative of ln y. Well, that's the same thing as just 1 over y times dy dx, because again, we're just applying the chain rule. And so now for our right side, we just have tangent x times the derivative of this whole thing. Alright, so what do we know? We can just apply the ln, the derivative of ln to some function formula. So which just states that it is going to be the reciprocal of the input of our ln. In this case, it's going to be 1 over sine 3x plus ln x plus 2. Alright. And it's going to be this times the derivative of the input, which is sine 3x plus ln x plus 2. And our right side here stays the same. Ln sine 3x plus ln x plus 2 times secant squared x. And so let's just try to simplify this whole thing here. So it's just gonna be the derivative of this whole thing over this, because now they're just being multiplied together. And so let's just try to compute this first. The derivative of sine 3x plus ln x plus 2. Well, here, the derivative of sine 3x, well, that's just cosine 3x times 3, because, again, chain rule. And now for the derivative of ln x plus 2, well, that is just going to be equal to 1 over x plus 2, because that is what the formula states. And so we can just put this whole thing up here now. That gives us 3 cosine 3x. That plus 1 over x plus 2 all over sine 3x plus ln x plus 2, which is just our denominator. Now let's write this whole thing again. So we get 1 over y times dy dx is equal to tangent x times 3 cosine 3x plus 1 over x plus 2 all over sine 3x plus ln x plus 2. And it's going to be this plus ln, I'll just square bracket, sine 3x plus ln x plus 2 times secant squared x, which is just this right there. So that just stays the same. And now we want to isolate for dy dx, because ultimately that's just what we're solving for, the derivative of function y in respect to x. And so the only thing to get rid of is the 1 over y. And how can we get rid of that? We just multiply both sides by y. And we can just write y, but you also notice that y is a defined function. So we must plug in that whole thing. So what we're going to be getting is, okay, so it's a little small, but it's going to be sine 3x plus ln x plus 2 all to the power of tangent x. And it's going to be that getting multiplied by, here in this case, I'm just going to put the tangent x inside this bracket right here. So it's going to be that being multiplied by tangent x bracket 3 cosine 3x plus 1 over x plus 2 all over sine 3x plus ln x plus 2 x plus 2 And it's going to be this plus secant squared x times ln of sine 3x plus ln x plus 2. And that right there, oh, it's really long, but that would be your final solution.